Well, hello everyone. It looks like we are live. How is everyone tonight?
Great, Neff. Thank you so much for having us, sir. Quite a pleasure.
Yeah,
I
thank you.
am Shalomful, as always.
Yeah, shalom aleichem. Um, sure. So I wanted to thank Smokey and Nicholas for being here, and for everyone watching. Welcome. Please hit the subscribe button as I have a lot of new content coming out soon. So what we're doing tonight is kind of doing a video response to from our last debate I had with Standing for Truth on radiometric dating. There are a couple of claims that I kind of wanted to dive into a little bit more, and just didn't have the time or the knowledge to really respond in that debate. He made actually a lot of different claims, so I kind of want to kind of take them down and tear them apart one by one. Um, I am.
And we get a front row seat.
Yes, you guys do get a front row seat. And so tonight we are going to be tackling the claim of um, accelerated radioactive decay. I'm going to do a separate response to the Bright Project, which was I think they were the people who actually proposed this mechanism of accelerated radioactive decay. And there's whole lot of problems that comes up with that.
Now, would you just, Neff, if I could clarify, do you have anything you're going to share on the screen, like a presentation-wise, or is it just to kind of discuss points?
Oh, yeah, I actually have a lot of stuff to share.
Okay. Then on that note, if I may, just so I can understand our function, whether to be more dynamic or passive, do you want us to kind of wait until you open us up to the questions based upon what you've covered, or do you want us to be a little more dynamic if there's something we need some clarification on to kind of jump in? Which would you prefer?
It doesn't really matter. I guess what we could do is I can maybe just give a presentation and all. I'm just going to go over in kind of.
I guess I want to give you the chance to make like a complete point, and then maybe
Right.
we, kind of give an idea or what we see in it type thing.
Yeah, definitely. And so what I'm going to do is kind of just go through my original opening argument real quick, just to give everyone
Sure. Beautiful.
of the
Perfect.
arguments that I made in that debate, and then kind of start looking at. There's a couple videos that I do want to show,
Beautiful.
and I did make a possible response to the heat problem, and that is what I'm going to get to at the very end, hopefully, and try and tear down what I like to call his rescue device.
Beautiful. Okay, yeah, well, let's get at it. Absolutely, I'm excited.
Okay, yeah, sure. So
All
I'm
right.
going to share my screen. To the Earth. So our topic it was on radiometric dating, and so I'm just going to give a brief overview of radiometric dating and what it is and the evidence for it. So radiometric dating is basically taking the concept of the half-life and measuring the ratios of the parent to the daughter element, and using that known age and that known decay rate to come up with the age of the sample. And if you recall from elementary school, the atom, of course, is the basic unit of the element, and the atom is defined by the number of protons. And an isotope is an element with more protons that has a little bit more neutrons in the nucleus. So, for example, carbon-12 would have 6 protons, 6 neutrons, and 6 electrons. So 666, carbon-12 is the devil's atom. Then we have carbon-13 with 7 neutrons and carbon-14 with 8 neutrons. And it's actually carbon-14 that is used for radiocarbon dating. And of course, you need to know a little bit about the 4 fundamental forces of nature and how they interact with each other. The weak force governs particle decay. So, as I will be explaining later on, if you want to have accelerated radiometric decay, you are going to have to change one of the fundamental forces of nature. And the result of doing that is catastrophic. So there are different types of decay. There's alpha decay, beta decay, gamma decay, positron emission, and electron capture. We're mostly focusing on alpha decay and beta decay. And how do we actually test the reliability of radiometric dating? Well, we can do that by testing the dating methods on known ages, by cross-checking it with other dating methods, And by sending the sample to multiple independent labs, if independent teams of scientists come up with the same result, that is good indication that the result is accurate. So let's just go through some myths right now. Myth number one is that carbon dating tells us the age of the Earth. That is incorrect. Anyone who tells you that doesn't really know what they're talking about. Carbon 14 is only used for samples less than 50,000 years old. Any sample that is older than 50,000 years old will just simply not have enough carbon in it. Myth number two is that the radiometric dating tells you the exact age of the sample. Again, that's not true. Samples don't come with labels telling us how old they are, as Kent Hovind would say. And if they did, we'd all go home and call it a day. But radiometric dating gives us a range following the 68, 95, 99.7 rule. So it kind of goes into like a little bit of estimate. In the media, you might hear it say, okay, this is 5,500 years old. And that's kind of like the target age. We're not saying that it's exactly that old, but it's from that time frame. So for carbon dating, it is a method for determining the age of objects containing organic material by using the properties of carbon 14. Living organisms have the same ratio of carbon 14 that is in the atmosphere, and carbon 14 has a half-life of 5,700 plus or minus 40 years. Thus, if we find an object that contains half the ratio of carbon 14, we can reasonably conclude that that object is around 5,700 years old.
And then, real quick question: did you
Yes.
say the carbon in the creatures is correlates to the amount in the atmosphere? Is that what you said?
Yes, that is correct.
Okay, I'm sorry. Okay, go ahead.
Not a problem. Get back to where it was.
Wait, do you know, does the carbon saturation in the atmosphere change with the oxygen saturation, or is it just kind of like, are we kind of going off the idea that the carbon saturation has always been the same throughout the history?
Sure. So this is an excellent question. So carbon 14 dating, we calibrate it using endocrinology and other methods because the carbon 14 ratio has, of course, changed in the past. And we know that very well. And what happens is in the atmosphere, nitrogen is constantly changed into carbon 14. And that's what's happening up in the atmosphere. And so that's where the carbon 14 comes from.
Gotcha. So how do we know what level of saturation, the Earth had at what point in time? Do we have methods of discovering that you know of?
Yeah, and that's kind of where dendrochronology comes in because we can take a look at tree rings. We can kind of take a little bit of a guesstimate and saying how much there was in the past.
Yeah, so this sounds to me like it's very key, and it's very key to the carbon dating, and it's kind of loosey-goosey and not very directly testable.
Well,
if I may finish this real quick. So what I'm kind of seeing is that like this whole thing really relies very heavily on a deep assessment, and we'd have to like review that assessment to see how reliable this is.
Well, let's let him finish too, because I do have a couple questions that popped up too, but I want him to be able to get through his thing.
Yeah,
go ahead.
Because I wrote down that I was going to talk about this, and now we've addressed it, so that's cool.
Okay. Well, no. We'll unhash. I'm sure a bit more too. Thank you for that, Nicholas. I appreciate it. Yeah. Go ahead, Neff. Thank you.
Yeah, sure, not a problem. And I will say this: that carbon dating, although it is accurate and quite reliable, it is probably the least reliable radiometric dating that we have. If we compare that to argon, or one of the isocron dating methods, those are far, far more accurate than carbon dating.
But if I may, those only work with like gaps of time that are much greater than that 50,000 year mark you specified, right? Like, right. As in, if the sample happens to be younger, you'll just get a radical irrational number, or
exactly.
Right. Okay. All right.
Exactly.
I have another suggestion or a concern there.
Okay.
It's the further back in time it is, the less directly we can test it. And yet we're assuming that the ones we cannot test as well are far more accurate. But I would need someone to make a good case of that.
And I will actually explain this later on. But I think it'll probably be that's just to get through my PowerPoint.
Okay.
And then
Yeah.
we'll talk
Sorry,
about
Neff.
that.
I'm sorry. Yeah.
No, no, not a problem. And then I actually want to kind of get into the issue of um, the issue really is um, standing for truth's claim and the right claim that the radioactive decay was faster in the past, such as during the global flood. If that is not even physically possible, then
Okay.
because what I'm claiming is that
So is it a challenge to the law of uniformity, kind of like at some point maybe the carbon could have decayed faster? That was the argument presented.
uh, well, it's actually much worse. And I'll but let me get through this and then
Okay.
we can
Okay,
get
that's fine. Yeah, go ahead.
Yeah, because I see what you're saying, David, that you're addressing something more specific, so you want us
Right.
to be aware of that.
Yeah.
Yeah. All right. Sure. So, um, we can actually do this. We carbon dated several artifacts, such as the Dead Sea Scroll, over 900 manuscripts, and the carbon dating shows that they were created between 2000 to 2400 years ago. The Great Isaiah Scroll, 2141 plus or minus 32. So that gives us in the time frame of around 351 to 296. And actually, King Richard III, his remains were found on February 4th, 2013, and they carbon dated the sample, and that it showed a 95% probability that the bones dated from around 1430 to 1460. And over in Oxford, the results both came about to be around 1412 to 1499, again with 95% confidence. And bearing in mind that the results cannot be later than 1583, the statistic modeling showed that the age range is about 1475 to 1530 with a 69% confidence. Next, we have rubidium strontium dating. This is a method that is used by um, taking a look at the isotopes rubidium 87 and strontium 87 and strontium 86. Rubidium 87 has a half life of 49.23 billion years, which is much longer than the age of the universe. This is an isochron dating method, meaning that we are measuring both the ratios of rubidium 87 and strontium 86, and the ratio of strontium 87 and strontium 86. Both of these ratios should be changing at the same rate. And if they are not changing at the same rate, we will be able to easily tell that in our sample. So in a closed system, we will be seeing something like this. The two isotopes are decaying at the same rate, and we can measure this in our graph, and the slope of the line dictates the age of the sample. Now, what happens if the system is open? We would see something that looks a little bit like this. So what happens here is that the strontium is leaking into the sample and making it look younger. So here is an actual case of this in the scientific literature. As we can see, we have a nice straight line. Um, the rubidium strontium isochrons and correlating samples. Um, Here yielding two isochron at 1438 plus or minus 33 million years, and a more uncertain 1074 plus or minus 74 million years, where the initial strontium 87 and strontium 86 value is derived from the figure here. Next, there's uranium lead dating. And this is probably the most accurate form of dating, and it relies on a series of decay chains: uranium 238, lead 206, and uranium 235 and lead 207. And it can be used to date rocks that formed and crystallized from about 1 million years ago to over 4.5 billion years ago, with a 0.1 to 1% precision. And this is actually most commonly used on zircon, though it is also used on other minerals. And what is quite fascinating about zircon is that it is it naturally is resistant to lead, and the reason why is because of the electron configuration in lead is just not compatible with the formation of zircon. So we can actually figure out that okay, all of the lead from the zircon must be as a result of the decay of uranium into lead. and the two different decay chains with different half-lives cross-confirm one another. Um, so yeah, as I was saying, zircon strongly rejects lead from its crystalline structure. It does, however, produce uranium and thorium. It is also very resistant to chemical weathering. Now, let's put it all together. So about 70 million years ago, as most of us probably learned in high school, when the at the end of the KT, where the dinosaurs kind of went extinct, there was a big asteroid that hit just off the coast of Mexico, and that led to a mass extinction event. And we actually see from the KT boundary, um, all throughout, there's a layer of iridium from this asteroid, and we have used these methods, very different methods from around the world, all yielding the same result, which simply should not happen by chance. Argon, you can see various locations all giving us 64 to 70 million years ago. So, in conclusion, radiometric dating, we can get a reliable date for the age of the Earth and various samples. If they were random noise, then we should be seeing them all over the place. They should not be consistent with one another. So that is so that was kind of my basic presentation for the debate.
Interesting. Interesting. Let me ask something real quick. How do like the samples that we're testing, like I get maybe the king like was probably like close enough in recent memory, like that's not maybe as huge of a deal, but like I mean, like, how do we know like how much carbon all these samples took in? Like if they're like if they happen to be living during a time of like I don't know some sort of increase of saturation of carbon, because if there's an increase of carbon in the environment, then it's also in the plants, and then it's also in the animals that eat the plants, and also from breathing the air. So like is it part of the model to consider that some animals or some specimens might have become hypersaturated with carbon, and maybe that might alter the figures?
Yeah, absolutely. And of course, scientists do take these into consideration. And there's actually something called the marine reservoir effect, um, which actually makes marine fossils and marine organisms appear to be much older than they really are. And so scientists will not use radiocarbon dating for marine fossils.
Now, and like now the fossils, like, and I know the fossils, it's, you know, I mean, it's mineralized organic matter, but like, so like we know there was a set amount of carbon inside the specimen when it died, or when it was, I don't know, fossilized or whatever. Like, well, I mean, I guess technically it stopped taking in carbon when it died, right? Like, I mean, there's no, it's not breathing anymore, it's not eating anymore. That's like,
Yeah, and that's exactly right. So the
okay,
organism um, is no longer taking in carbon 14, and so that is slowly decaying away,
got
and
it.
we can kind of do that. But
So if that's the point where it starts and it's starting to decay away, is there anything that we know of where it could still absorb carbon from the environment, or is that just completely incoherent because of the fossilization process?
well, what can happen, and what happens in some samples is that fungi or dead skin or whatever can come in and contaminate the radio. And so
Oh,
as a result, it's the contamination. The contaminant is actually dated and not the actual sample. In fact, um, I think there was a case with the Miller experiment where Miller actually kind of took a dinosaur fossil that was covered in shellac and took it to be carbon dated, which was quite deceptive and dishonest on his part, but that's a story for another day.
mm,
And when they radiocarbon the sample, they were dating the shellac and not the um,
right.
right.
Okay, so if I can clarify that, then I think the general answer to Smokey's question might be no, because carbon is only biological. So, oh, but there are biological microorganisms all through the soil and stuff. So, can any of that carbon get into the samples so that it's not only a problem with people in the lab, but also a problem in the natural environment?
I mean, I'm sure it's possible, but then again, that is why we're given a range of dates, and that's also why um, scientists take very good care of their samples, and they really try to do the best they can. Now, let me ask you: would you agree with the radiocarbon date of the Dead Sea Scrolls?
Um, I wouldn't see a reason not to, but but in that seems really specific to me in the sense here you have some harvested. What is it? Papyrus? Is it what's the material made out of? David, do you know? I don't remember.
I'm not quite sure. It might be lambskin because that's what
Okay,
they were using.
Yeah,
so
and some of them are papyrus, and a couple of them are made of metal.
oh, cool. So we have this dating of these materials, which we kind of know, I guess, fit like within a reasonable, like less than 50,000 years, right? Like for sure. So like we use that and we know what the material is, we know where it came from, and we know the rough period of time, and no reason for us to assume there was any like hypersaturation of carbon, in this particular window of time, right? So like for me, there's enough sustainable information to kind of rely on that. But now I'll give it the caveat. How do we necessarily know when we're dating a fossil if we're supposed to use the radiocarbon 14 or one of the longer ones? Like, because I know you said in your thing, specimens don't come with a label. So like, how do we decide which one to use and which one's going to be accurate?
Well, that's actually why scientists actually use multiple dating methods, and sometimes samples are used. There was one sample used 6 different dating methods, and that's all cross confirms and cross checks. It's kind of like a check and balance to make sure that it's correct.
Well, and they're
Yeah.
all testing for that same spectrum of time, or
Well,
like.
well, I just want a chance to answer the Dead Sea Scroll question while it's
Yeah,
up to
oh
you.
yeah, I'm sorry, Nicholas. Go ahead. I'm sorry.
So, the whole thing with the Dead Sea Scroll question for me is just, yeah, all this difficulty with the whole scientific world on this and trying to clear this all up makes that, like, I don't know exactly what to do with that evidence. So to me, that's kind of a red herring here because I would seek for this discussion to inform that, but probably not the other way around in this specific context of us all talking.
Okay. Yeah.
And then
Yeah.
we're on the topic of cross confirmations, which, yeah, that's what David brought up. And I was just saying, yeah, I would need to know more about these cross confirmations because we know that, like, they're using each other's cross confirmations and it might end up like in total just being circular reasoning. And I think there's a lot of we want to be educated on these details and able to assess and tell if it's BS or not because we know BS exists, but we know that also authentic science exists, and we want the chance to be able to look and decide the difference and do our best.
Yeah. Before we get into that, I kind of want to get back on track of the actual thing that we are actually going to be kind of wanted to talk about, and that is the what are the consequences of accelerated nuclear decay? Because that's kind of the original topic.
Sure. Yeah.
What exactly are the consequences? What would happen if the as if rate project in Standing for Truth would claim um, what happened if it was super accelerated in the past. So King Crocoduck actually did some mathematics on this, and I'm just going to share this video real quick.
Historical science. Assumption 2, that all daughter atoms measured today must have only been derived in situ radioactive decay of parent atoms. In other words, but you don't know that. There's a lot of evidence that that's not so.
Wrong on both projections. Ideally, we can know the initial conditions of the isotopes if we find a sample in a closed system where nothing could potentially contaminate it, but oftentimes we have to use isochron dating methods where surrounding samples of the same element in different isotopes are all analyzed, along with the decay rates and initial daughter isotope concentration. You do not need to know the parent isotope concentration for this method, and in many cases, the assumptions of the initial conditions are perfectly reasonable. Take the potassium-argon method, for example. Minerals that are dated this way can be assumed to have a negligible amount of argon in them initially because argon is a noble gas, and noble gases don't form anything other than glow sticks and balloons. Seriously, though, argon doesn't naturally react with anything but itself, so it's reasonable to assume that none of it helped form the crystal structure that's characteristic of whatever's being measured. With carbon dating, we know that the amount of the parent isotope, carbon-14, varies with time, but we can calibrate the initial
I don't
amount using other methods
like
like
words like
dendrochronology. There are
that.
other examples that show
I don't like words like assume inside of like we can safely assume. Is this science still?
Yeah.
You know.
I'll get to that in a minute.
Okay.
Yeah. Let's finish watching this short section.
All right. That's okay.
why Ken
Can
Ham's objections
can you
are
rewind to
nonsense,
just
but I think
before
that
it
the
said
point is
assume
made.
so that I can follow?
Sorry, Nick. Yeah.
Well, no, I also want to follow what you're saying because I missed it.
You do not need to know the parent isotope concentration for this method, and in many cases, the assumptions of the initial conditions are perfectly reasonable. Take the potassium-argon method, for example. Minerals that are dated this way can be assumed to have a negligible amount of argon in them initially because argon is a noble gas, and noble gases don't form anything other than glow sticks and balloons. Seriously, though, argon doesn't naturally react with anything but itself, so it's reasonable to assume that none of it helped form the crystal structure that's characteristic of whatever's being measured. With carbon dating, we know that the amount of the parent isotope, carbon-14, varies with time, but we can calibrate the initial amount using other methods like dendrochronology. There are other examples that show why Ken Ham's objections are nonsense, but I think that the point is made.
Assumption number 3, that the decay rates have remained a constant.
This is my personal favorite creationist argument because it outlines just how desperate creationism is. To understand what I mean, you have to know a thing or two about the weak nuclear force, which is one of the 4 fundamental forces that shape our universe. The weak nuclear force, as with the other forces, can be reduced to individual components, or quanta, called the W and Z bosons, which are subatomic particles. These guys are pretty massive, and they're the ones who are ultimately responsible for radioactive decay. While we can't predict exactly when and where decay will occur in an atom, as the process is probabilistic and spontaneous, we do generally understand why it happens. An atom is most stable when the forces on its nucleus are balanced. The less balanced the
Hey,
forces,
David,
the more
quick
likely it
question.
is to experience radioactive decay.
Do you think that simulation's accurate?
Well, without actually checking, I'm assuming it's accurate. Again, this is just a sample.
Well, no, I say it because it looks like I mean, it says it's expelling nucleons, which I'm not sure exactly what that is, but
yeah, it's definitely it's a simulation.
when we look at, when we observe, the actual expelling of like electrons in an atom, like we actually look at it on the quantum level, it looks like particles, but when we are not looking at it, it acts like waves. That's one of those incredible,
right, and that's kind of why this is kind of a simulation of what happens in there.
like, because it looks like it's operating like waves, but we're looking at it. That's why it seemed kind of like weird.
No, I see a particle cloud.
Yeah,
with currents in
I'm
it.
not quite exactly sure what it is, but that's kind of like
That's fine.
that's
Yeah,
kind of off
it
topic.
made me think, like, and I was like, oh, that's interesting, because usually I would think if it was a simulation, it'd be showing them like emanating as particles, not waves. But okay, whatever. No, I get it.
As long as it's paused, may I ask a question, David? Because
Go ahead.
there are factors that can be applied to change decay rates, are there not?
No, and that's exactly what he's about to get into.
Oh, okay, let's go.
Okay, so you can't put anything in an environment and do things to it and alter the decay rate?
Nope, and this is why.
Okay, let's do it.
K. At atomic scales, gravity is pretty much negligible, but the electromagnetic and strong forces are not. Furthermore, these two forces don't really cooperate. The electromagnetic force is based on charges, which are either attractive or repulsive, but the strong nuclear force doesn't care about charge. All that it cares about is distance, kind of like gravity, except at much smaller scales. Plus, the positive and negative charges of the electromagnetic force aren't always balanced inside of the atom, so imbalances of forces in the nucleus of an atom are essentially inevitable. Radioactive decay can therefore be thought of as the mechanism by which atoms try to become more stable. In order to believe that the rate at which certain isotopes decay isn't consistent over time, you have to believe that the conditions that lead to radioactive decay have likewise not been consistent throughout time. Therefore, you have to believe that the forces acting on the nuclei of these atoms have varied tremendously. Remember that Ham believes that the Earth is 6,000 years old, about 3/4 of a million times younger than the age that we measured using the uranium lead dating method. Ken Ham has to believe, at least for uranium 238, but also to a lesser extent for the other radioactive elements, that the electrical and strong nuclear interactions that took place inside of these atoms were so violently unbalanced that the atoms decayed at over 750,000 times their observed rate of decay. And in order for that to be the case, the relative strengths of the electromagnetic and strong forces had to be significantly different in the past, which itself would have resulted in nearly every equation in physics to use different constants. Just take the two most fundamental constants relevant to electromagnetism: the vacuum permittivity constant and the vacuum permeability constant. The law that relates charges to the electric force and the law that relates the flow of charges to the magnetic force would have had to rely on significantly different constants of proportionality, which is a pretty big deal when you remember that everything you see is held together by electrostatic forces and are surrounded by magnetic fields. The laws of physics really do have to be different in order for Ken Ham's model to work. The irony here is that earlier, Ken Ham claimed that the laws of nature are uniform. But it gets even worse when we consider the consequences of accelerated decay rates. In fact, I can confidently say that this leads to the most breathtaking failure that creationism has ever produced.
Yeah, this is just trying my patience. I'm just like, I mean, not criticizing you, David, but just talk about the video.
Who is this pretentious weird person? Who is this?
This is a guy named King Crocoduck.
Oh, that makes sense. Okay, no,
Yeah,
yeah,
he's a physicist, so he knows quite a lot about this stuff.
gotcha.
Well, if I may for a second say, well, we have it on pause during this part that's like trying to talk to us emotionally. So it's obviously kind of like propaganda based. It's trying to make us uneasy, like an emergency's happening, and make us feel nervous so that when the next information comes up and we have nervous emotions, we might think it's doubt, kind of a thing.
Yeah,
But also,
why don't
well,
we,
Smokey asked about if that was a simulation earlier and if it was accurate, but we saw a series of simulation graphics, and one of them was two fists crashing into each other. So I don't even trust I don't even trust the graphics of minerals and stuff. This is just a video made to look good, and so far there's not enough information for me to assess anything relevant. It's just empty claims without argument from my
yeah,
perspective.
can we actually finish the clip before we comment further?
Sure.
Yeah.
In SI units, we measure radioactivity in becquerels after the guy who co-discovered radioactivity. 1 becquerel is equal to the release of 1 radioactive nucleon per second. According to the physics department at the University of Idaho, a kilogram of uranium-238 releases on average about 25 becquerels, and the 5th edition of the McGraw-Hill Science and Technology Encyclopedia calculates that the Earth's crust contains 10 to the 17th kilograms of uranium-238. That means that the total amount of radioactive nucleotide output on Earth that is accounted for by uranium-238 is about 1.2 times 10 to the 18th becquerels. Now, the decay rate of an isotope is linearly related to both its age and the parent-daughter parameter. The parent-daughter parameter will vary with each individual sample, but the average decay rate will not for the reasons that I've already outlined, so the age of the Earth should correspond to the radiometric decay constant. Since Ham's model stipulates that the age of the Earth is 760,000 times less than its measured age, the decay rate for Ken Ham's model must have been an average of 760,000 times its actual decay rate, or about 9.1 million becquerels per kilogram. That means that the flux of Earth's radioactivity due to uranium-238 alone should be a total of about 9.1 times 10 to the 23 becquerels, or an average of about 4.6 times 10 to the 15th becquerels per square mile everywhere on the planet. To put that into perspective, the Fukushima nuclear disaster is estimated to have released a total of about 5.4 times 10 to the 14th becquerels. That means that in order for Ham's model to work, the planet released an average of about 8.5 times more radiation than Fukushima did in total every square mile, every second for the past 6,000 years. And that is being generous, as not only did I not take into account that there was more uranium and therefore more net radioactivity in the past, but also because I assumed that Ham's ridiculous decay rate was constant before magically changing to its current value when we started measuring it. This is a generous assumption because any non-constant function for the decay rate of uranium-238 would have yielded even more catastrophic results. Bear in mind, by the way, that I only considered uranium-238 in this calculation. Do the same calculation for every other major radioactive isotope out there, add them all up, and the true extent of this argument's failure will be fully revealed. I have seen creationist arguments fail time and time again, but I have never seen any of them fail quite as spectacularly as this one.
They just
All right, so basically the issue with accelerated nuclear decay is that it's physically impossible without changing one of the four fundamental forces of nature, and without and not even considering the amount of heat and energy that such an accelerated decay would have produced during the global flood and during the past 6,000 years. Now, I actually do want to play another clip. This is a much shorter clip. This is from Standing for Truth's debate. He made the same argument with me as he did in this debate, where he actually tries to address this entire heat problem. So, why don't we take a quick listen to what Standing for Truth has to say about this?
Okay, and I have specific things that might need to get dug into, as well as general things to say. So just a heads up on where I'm coming from.
Yeah, sure. So let's finish this first, and then we'll get back to you.
Yeah.
For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
So a bunch of creationists back in 2005 and a little bit earlier decided that they were going to disprove radiometric dating, and they couldn't. They had to admit that a young Earth position cannot be reconciled with the scientific data without assuming that exotic solutions will be discovered in the future. No known thermodynamic process could account for the required rate of heat removal, nor is there any known way to protect organisms from radiation damage.
As far as speeding up the decay rate, I've given a few examples with fission tracks and radio halos and, for example, helium in my opening. But according to a catastrophic plate tectonics model, the CPT, meters per second plate movement, would produce new oceanic crust, replacing the old one. This new oceanic crust would show the same age through isochron dating since it formed all at the same time. I wanted to address real quick, I believe she said, how would we explain with heat? Yeah, a lot of heat would be generated, but the massive amount of water that was on the Earth at the time based on the flood would shield Noah. And the RAPE project explains this. So they do have answers, and it would also shield the animals on the Ark. If you have a mile or more of water, of course, we even use water as air probably knows, in a nuclear reactor to protect and to shield things. So this would not only shield from radiation, but it would also take up much of the heat. There's also a ton of evidence that at the breaking up of the fountains of the Great Deep, there would have involved supersonic steam jets that would have taken up most of the heat up into space and more.
All right, so that's basically standing for truth rescue device here, and that's pretty much he likes calling things rescue devices. And so I really wish Standing was here to actually talk about his model real quick, but
Yeah, David, I must apologize. I accidentally got distracted and missed what Standing was telling me. I don't know if you can briefly summarize. I catch on really easily.
Well, he was.
actually, let me just. Do you just want me to play it again?
Yeah, just play it again for Nick.
Yeah, I'll pay close attention this time.
Yeah,
My
go ahead.
apologies.
Nick, maybe if you don't mind, after the video's over, let me just maybe say my quick little things. And I got to run and grab myself something to eat before I start my stream.
Yeah, that's fine.
And I mean, you can take the rest of the time with David and kind of explore that a little bit. I just a couple quick things to get out.
Yeah, sure thing.
For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
So a bunch of creationists back in 2005 and a little bit earlier decided that they were going to disprove radiometric dating, and they couldn't. They had to admit that a young Earth position cannot be reconciled with the scientific data without assuming that exotic solutions will be discovered in the future. No known thermodynamic process could account for the required rate of heat removal, nor is there any known way to protect organisms from radiation damage.
As far as speeding up the decay rate, I've given a few examples with fission tracks and radio halos and, for example, helium in my opening. But according to a catastrophic plate tectonics model, the CPT, meters per second plate movement, would produce new oceanic crust, replacing the old one. This new oceanic crust would show the same age through isochron dating since it formed all at the same time. I wanted to address real quick, I believe she said, how would we explain away the heat? Yeah, a lot of heat would be generated, but the massive amount of water that was on the Earth at the time based on the flood would shield Noah. And the RAID project explains this. So they do have answers, and it would also shield the animals on the Ark. If you have a mile or more of water, of course, we even use water, as Eric probably knows, in a nuclear reactor to protect and to shield things. So this would not only shield from radiation, but it would also take up much of the heat. There's also a ton of evidence that at the breaking up of the fountains of the Great Deep, there would have involved supersonic steam jets that would have taken up most of the heat up into space and more.
Okay, I got it.
Cool.
Yeah. So basically, this is kind of the thing that I wanted to tackle, showing why number one, the accelerated decay is completely impossible to begin with. I'm going to talk about fission tracks and all of the other stuff in a separate video, but kind of wanted to see if number one, whether or not it's even possible to accelerate the decay rate so quickly, and number two, if his solution is even viable. So Smokey, go ahead and get what you wanted to. If you have anything you wanted to say, just get that out now.
Thank you so much. Yeah, I had a couple things here that I pulled up that I kind of just wanted to ask your opinion on. And the first was to do with like the choice. We touched on it briefly, but the choice to do either the radio carbon dating 14, the radio 14 carbon dating, and that would give us ages of anything less than 50,000 years. But like we all kind of have, I guess, assumed inside, the scientific community, that because all the dinosaurs are so old, like they lived, tens of millions of years ago, 65 million years ago or whatever, that like there's no way we would ever try radiocarbon 14 dating on them because there wouldn't be enough to survive. But it seems like we do find like carbon inside dinosaur bones. And there's this, if you don't mind, maybe I could share my screen real quick.
Yeah, definitely share your screen. No.
Now, granted, this is I think a creationist source, but they're pulling a source that isn't a creationist source, so I think it might be at least worth looking at. And you can just tell me your thoughts real quick. So this is carbon 14 dating in dinosaur bones, and I guess there was an abstract that was submitted. Members of the paleochronology group presented their findings at the 2012 Western Pacific Geophysics meeting in Singapore, August 13th through 17th, a conference of the American Geophysical Union, AGU, and the Asia Oceania Geosciences Society. And I guess they did carbon dating, the 14 carbon dating on the dinosaur bones, and they found that they were less than 50,000 years old, and they just kind of blanket dismissed it and said clearly it's got to be an error because we know dinosaurs are really, really old. So it almost seems like even if there might be evidence to the contrary, maybe the scientific community wants to not undermine all the other assumptions and stuff that's been done in this field. What do you think about that?
This is something that I'm going to try and do some more research on and put in a separate video.
Do you want me to give you this link? You want me to put it in the private for you?
Yes, that'll be perfect. So yeah, definitely get that to me as a private link. And this is going to be a separate video on the carbon 14 and diamonds and fossils.
And also the soft tissue, maybe, if you kind of have that broached up. Do you know what I mean? The soft tissue.
Yeah, from Dr. Schweitzer.
Right, Dr. Schweitzer. Right, that one. Yeah.
It's actually interesting because Dr. Schweitzer is an evangelical Christian.
Right.
And one of the things she said in her in an interview with BioLogos is that I wish young Earth creationists would stop misrepresenting my work.
Right.
So I think it'll be nice just to do a whole video just on the soft tissue.
Well, and do you think you don't do you have a quick answer to how you think maybe the soft tissue survived so long, or do you think it's just an error? What do you kind of, what's your gut kind of telling you?
Again, this is something for a separate video.
Okay, that's fine. Okay, no, I won't.
If you actually read the original paper, and if I can, I'm going to give you a because I know Potholer 54 did a complete video going into detail on that.
Okay.
The soft tissue was after it sat in demineralized solution for a couple of weeks, so keep that in mind as well.
Okay. Well, I mean, but she did pull collagen proteins and stuff, things that clearly would be produced. That wouldn't explain it away, would it? Because she got actual organic, compound proteins that aren't the type that you could just explain away with contamination. And I remember people said, well, it could have been bacteria and this other stuff, and she was just testing for that. But then she actually tested the proteins themselves to debunk it and found out, no, these aren't contaminants. These are things actually produced, in this type of cellular organism. Isn't that, is that part of it or no?
Yeah, and again, this is something that is definitely worth a video in and of itself.
Okay. If that was the debunk, I just wanted to get it out there because I didn't feel like that was the debunk.
Maybe I could play a quick short clip if you want. I can play a quick short.
Well, it's not a huge deal. If you want, you can put it in the chat and I'll save it and I'll go watch it. But I should run out.
Yeah, because we might want to try to stay focused on what David's presented.
Yeah, and Nicholas. Yeah, Nicholas kind of is probably better to do that with standings perspective. So I should hand it off to him. So, we won't worry about it, David. That's fine.
Yeah.
I just wanted to throw that out there. But thank you so much for having me on, and that was really interesting and informative. So thank you for that.
Yeah, and so I will see you in the in about half an hour.
About
hopefully,
half an hour. Yeah, I will do my open mic night. Sure, absolutely. Yep.
Yeah, sure. So everyone at 9 p.m. go over to Smoky Saints channel and have an open mic session with him.
Beautiful. Sounds good. Awesome. Thank you so much, guys. God bless you, Nicholas. I'll talk to you guys later.
Shalom, brother.
Bye bye.
All right. So yeah, and I this conversation, of course, got derailed a couple times with different topics coming up, all worthwhile for its own video. But going back to the original issue is whether or not accelerated decay is even possible.
Yeah,
and
so
whether or
if
not,
I may, well, may I start with something that I asked you about if there's factors that can affect it, and you said the video would address that, and it never addressed it once.
yeah, it did. And so as I was saying, both in my presentation and in my video, if you want to have hyper accelerated nuclear decay, you are going to have to change one of the fundamental forces of nature. And when
No,
you actually do that,
that's the standard rate. That doesn't address whether or not factors, whether or not factors conjoin with the standard rate for the final result. That was never addressed.
like what do you mean? I don't understand what you mean. Like, are you saying are you challenging whether or not the decay rate is constant?
Yeah, because if there's factors beyond just that one law, if there are other factors, then those factors would affect the decay rate. There was nothing in there that demonstrated or even cited anything. There was nothing indicating that there are no other factors besides the one law. It was just they just so I didn't really get anything from that other guy's video that I saw. I didn't see anything in it.
Well, again, as he was trying to say, what would happen if that actually was the case? And
Well, he was saying if the law of nature changed, he never addressed if there's other factors or not.
and again, there's no other factors. As I said, he actually did show what exactly would be the consequences if that were to happen, such as the hyper accelerated, the insane amount of energy and heat that would have been generated during such event that would pretty much have killed everything off.
Yeah, and then and I don't really understand precisely what the order of cause and effect is between the heat and the radioactive decay rates. But yeah, I mean, there's a number of points on why I was very dissatisfied with the idea that these dating methods are reliable. But if you'd rather just focus on standings points and let the dating methods in general be a different debate, then I'm down to do that.
Yeah, I just kind of want to focus on standings point real quick.
Yeah, so I didn't see anything much wrong with it. So then I would leave it up to you to start saying, what your problems were with it.
Yeah. So the problem is, as standing for truth and ICR and all would agree that it would cause an immense amount of heat and radiation. What he is actually proposing is a rescue device, and this rescue device makes no sense physically because the water itself would be piping hot. All of the marine organisms would be dead. None of them could possibly survive, and the ark would have burnt up. There is simply no way that the amount of water itself, the water alone. Yeah. Hey, Creationist, do you want to jump in the chat? I was thinking about inviting you too.
Can
Hey,
we focus on the water for one moment? Because water retains extremely large amounts of heat. So if we were just to quickly say whether or not water can absorb a sufficient amount of heat to really account for much of this, I would first think yes. So I'd like to hear why it would be no instead.
Yeah. Well, the thing is, not only are you have not only do you have to take into consideration the amount of heat and radiation that is coming from the hyper caffeinated um, accelerated nuclear decay, but you also got to factor in what he is proposing is catastrophic plate tectonics, where all of the continents are breaking up all at the same time. So you have a ton of energy from. Um, Not a problem, Dr. Dan. Hope you're enjoying the stream. Um, and Dr. Dan, I hope you come over to Smoky Saints channel for the open mic, open conversation. But as I was saying, what he's getting at is the water itself would be piping hot. So none of the marine organisms could possibly survive. The water would not have protected them. Plus, you got the breakup of the continents going at an insane.
Oh, wait, what I don't understand is the water is piping hot. Is that because it absorbs the heat, or you're saying it's piping hot before it absorbs the heat, so it can't? And then why? So
Well, it would have been hot due to the radioactive decay and from the all the energy going on.
oh yeah, so that's what Standing's saying is the water would have absorbed the heat and
But that's not the case. That's physically impossible. And I want to challenge. I want to actually challenge Standing to actually prove that it's even physically possible, because you're releasing a lot of not just the radioactive decay heats, but also that from it just here's something from talk.origins. An estimated release of 10 to 28 joules from the seduction process, which is more than enough to boil off all the oceans. Um, so, um,
okay, but a number like that is very theoretical and uncertain. Yeah.
yeah, they're the same thing here. The thing is, standing for truth, rescue device simply um, is not physically possible. That's the point that I'm trying to make. Because and none of the marine organisms would ever survive such a catastrophe.
Yeah, and I get it. I'm not trying to be stubborn. I'm just trying to push back until there's opportunity for me to like see why I would agree that that amount of water can't absorb um, that much. So how much energy could the water absorb? Because if you said 10 to the 28 joules
No,
would fill up all the oceans, is that what you said?
no. I'll read the quote from Talk.origins about runaway subduction. Um, the estimated release of 10 to the 28 joules just from the seduction process. That's just an estimated thing. Um,
Yeah, and then that would be too much. So what I'm asking is how much can the oceans absorb? Because I have no idea like the scale of what I should be assessing. I need some scale before I can start being convinced.
Okay, so here's the thing. Okay, I found something from the USGS.gov. Um, Precisely, water has to absorb um, 4184 joules of heat for the. So yeah, I'm not quite sure exactly how much it can absorb, but again, everything would just been boiling hot, and so much energy would have created from not just the radioactive decay, but also from the breakup of the continents.
Yeah, and then heat rises and I mean space is cold, so heat can also and the hotter one object is next to a cold object, the more heat it will exchange, right? So
Yeah.
how much
Yeah,
how much
that's kind of
how
what I'm
much
saying.
how
And
much
this
heat
is a good
could go
point for
out
Dr.
into
Dan. We know the specific heat of water and how much energy would be released if you compress all the nuclear day into the timeline. It would boil away all the water, and even the rate project did the same math and agrees. So again, the idea that the
this is
water
still
protects.
more of enough of it's theoretical and speculative that I want some sense of scale to assess. I don't want to just like be treated like I'm too stupid to be
Yeah,
given.
I understand, and I wish I had more of the mathematics with me
And
here.
I don't mean to sound sensitive saying too stupid, but in the sort of
Yeah,
long term
I
thing,
know you're
it's
not
like
too
that's what we
stupid,
keep
and
asking for. We keep asking for like more of the details so we can assess it. Why are they afraid to have a full discussion with us? Why do they keep like just trying to say, just trust the scientists? Like, we're interested in this. We're spending hours and hours on this. We're ready for like the details beyond the claims.
Uh,
But that was just responding to Dr.
Yeah.
Dan's statement.
Yeah, contradictory. Here we go. If the water absorbs the heat, it doesn't radiate outward.
When I talk about some heat leaving the atmosphere and some absorbing by water, I don't see any contradiction there. I think it
Yeah.
was very weird to just assume that I was proposing a contradiction instead of assuming that I might make sense. Like Dr. Dan, I'm not stupid.
Well, I know. But I'm just gonna share ICR itself. I'm just gonna share this. This is from the ICR. This is from the rate project. Um, the heat problem resolved. This is from ICR themselves. The great concern is to both the supporters and skeptics of the rate project is the issue of how to dispose of the tremendous quantities of heat generated by accelerated decay during the Genesis flood. The amount of heat produced by a decay rate of millions of times faster than normal during the year of the flood could potentially vaporize the Earth's oceans, melt the crust, and obliterate the surface of the Earth. The right group is confident that the accelerated decay they discovered was not only caused by God, but that the necessary removal of heat was also superintended by him as well. In other words, God did it, it's a miracle. Thus, it's not scientific to begin with. So basically, they had to claim a miracle. Dr. Russell Humphrey, a member of the rape group, has suggested one possible mechanism that the cooling of Earth by the expansion of the cosmos, which of course makes no sense either. Um, so again, the ICR
What
themselves,
was that about the cosmos?
uh, basically trying to say that the expanding cosmos would cool it down, whatever. But pull up Braid's report. That is crazy. I can't find their exact report right now, but that is definitely something that I would look for.
Yeah, and just to clarify what I'm talking about, like, I'm not saying I expect Dr. Dan to have the information, but he was just kind of repeating what David Neff already said. And like David Neff and I are already having that discussion. So, I mean, that's all it really is. Like, I don't really like when repeating the same thing is taken for strengthening the argument.
Yeah. So
Personally, as
I'm
a
gonna.
debater and all that.
Yeah, I think for now I'm gonna send this video over to Standing for Truth to see what he has to say about our arguments in response to that. But just his whole idea of how the water itself would protect Noah and the ark and all that, and just flies in the face of reality. I'm sorry, Standing for Truth. I love you, man, but you're but you have a rescue device of your own.
Yeah, and I think it's fair to call it a rescue device. Then the question is it a fair one or not? And of course, like, if God's involved, it doesn't have to be too likely. But assessing whether or not there's a way that it sort of physically makes sense, I mean, that sure does help also. So, yeah, I look forward to seeing you and Standing get to hash this out because
Yeah, and that's why I really, really wish Standing was here so I can actually cross-examine him with this information here. Um,
yeah,
yeah,
so I'm like sort of surrogate for Standing's audience, and
yeah.
I think
And by
that
the way, Nicholas, I love you, man. I really do appreciate you coming on and actually spending some time
thank
with
you.
me
You're welcome.
tonight. Trying to think what else is going
Well,
on.
standing at a few points like the newness at the bottom of the ocean, do you want to express your problem with that idea that like all this stuff would be newer and would wait, what's he saying there when he's talking about it?
Yeah, my apologies. My contribution was the specific word. I missed the start, so my apologies if the rate answer is a miracle already came up. It's not a problem, Dr. Dan. This is kind of a response to a debate that I had with him, and yeah, I don't think this actually came up yet, but God did it is never a scientific argument. And if you have to invoke a miracle, your model is a failure. Period.
Well, I do also think that if we have like I think intelligent design, like what Steve Meyer does, is a very valid approach, and he's very careful about it. But I do agree that in general, God did it is outside of using a scientific approach. if your answer is that simple, that's for sure. So yeah.
Oh yeah, and there's one more massive problem with standing for truth's model of accelerated decay, and that is this: we have stated meteorites in space rocks and even the moon rocks itself with radiometric decay, and there is no hint of any accelerated decay in them. And moreover, they also give like when we actually date meteorites and stuff like that, they come back to 4.6 billion years old in that time frame, consistent with an old Earth. So if Noah's flood did cause accelerated decay on the Earth, then rocks and material from space should not be affected by the um, accelerated decay. So how would Standing for Truth probably explain that? I would definitely like to hear his answer to that as well. So, do you have any thoughts on that, Nicholas?
Yeah, that point sounds pretty solid. So that's one I'd be interested to like see data on in here. Like,
Yeah,
yeah.
yeah, definitely. Um,
And then I'd like to speak for myself instead of standing for just one moment.
yeah, go right ahead.
Maybe you and I sometime would even enjoy having a full discussion because like my approach to being skeptical about radiometric dating is very different, and it might be more sophisticated than most lay people creationists, you know. But I think in general, it's the same idea as most lay creationists. So we might enjoy discussing that sometime because yeah, it's quite different from what Standing's presenting. I don't really know much about what Standing's presenting.
Yeah, so Standing for Truth, I hope you we can actually sit down and talk about this together one day, or if you want to do a video response to this, that is fine with me as well. So you definitely have a lot to answer for in your response. So I do want to tell you about a couple of things that's coming up. First, at 9 p.m. tonight, Smokey Saint is doing an open mic on his channel. Please go check it out. I'll be there. We'll be talking for a few minutes, or however long we decide to chat
Yeah,
for.
and that's Eastern Standard Time, so that's coming up in like 20 minutes.
Yes, indeed. So I hope to see you all there. If you have not already subscribed to my channel, please do. I am working on a brand new video series called The Foundational Fallacies of Creationism. In this series, I will be um, discussing the actual logical fallacies behind some of the creationist arguments. Um, and last but not least, I am planning on doing an open mic talent night on my channel sometime this week or next week. So if you want to sing, play the piano, play an instrument, tell us a joke or whatever, by all means, this is the night for you. I'm still hashing out the details and figuring out how it will all work. So a lot of work, a lot of stuff to look forward to on my channel.
Yeah, guys, and for David Neff's channel, go to the bell and set it to all because if you want to like catch live streams and stuff, then that's the way to do it. You make sure it's set to all.
Yeah, definitely. Anyway, guys, I will see you guys in about 15 minutes over on Smoky Saints channel. Bye bye, everyone.